Maveneer, we take complexity and we break it down into understanding the right level of abstraction of the problem. Can we peel away the problem into its base layers into what matters? Focusing on what matters is the key here. Not getting distracted by all the bells and whistles and buttons around the problem and focusing on what's the engine driving the complexity that we see. There I was working on a new system that had a new sorter and conveyor system, and the controls operators were struggling to get the gapping correct onto the cartons. And we went and we broke down the problem by hand on paper, and we brought it back and we said, look, this is what matters. All this stuff in the middle is irrelevant. You're wasting your time. It's the beginning, it's the end. Those are the key factors when you're doing gapping. And so we broke that down very quickly. We made the controls very simple, and it worked much better than anything that they had done thus far. All right, so complexity, what does this mean? So complexity is often how people describe systems that they don't understand, right? You look at something, look at all the bells and whistles, that looks very complex. Think of the first time you started driving, for example. It seemed complicated, all the rules of the road, all these buttons and knobs on the steering wheel. What do I do? If you can recall that age of your life. Once you gained that understanding and you really learned the rules and you broke it down to what actually mattered, steering the wheel, pushing the accelerator or the brake, it's really just a few key first principle aspects of driving that matter, and the rest is all secondary or just used in special cases that are pretty easy to remember once you've done it a few times. So these complex systems can be very overwhelming and nuanced, but if you approach the problems with what we call a first principles approach, this first principles approach is very common in math and science, physics type problems that we solve. We quickly peel back the layers of complexity. We take away things that are secondary or not necessary to try and reveal that simplicity and get down to drive into what actually drives this problem from what we call a first order. What's the main driver? How does it apply? Well, in our industry, we find that we require a clear understanding of math and physics to solve all the things that we see in warehousing, distribution, supply chain, etc. But most of it requires a high school level of math and physics. But if you understand those basics, you can quickly peel away that complexity and gain pretty significant clarity quickly. So at Maveneer, we often are brought into a full operation. We're brought in the swing of things while it's running, all the people, all the equipment moving around. And at first it can be very overwhelming and very complex. And one of our first tasks is to break down that complexity, really see what are the main systems that are driving it, what are the people, what are the physical pieces of equipment, and what are the maybe software systems that are running it. This will apply both to something physical, as I mentioned, like engineering design. Maybe we're designing some piece of physical equipment, or it could be something in software. One of the worst things you can do that we often highlight at Maveneer is to go look at some other example, because oftentimes you see something and it looks more complex than it really is. Whereas if you start with a blank piece of paper, really do that from a first order principles, you don't jump to some other person's solution. You really lose that learning skill and you aren't able to do it yourself and really understand from the ground up. And we did this as a key example. We did this with the Maveneer print and apply. We started developing this a few years ago, and we actually hired some people that had never seen a print and apply in their life. And so they didn't have this background of what it could look like, what people had done before. It was blank page. I need to put a label on a box. What's the best way to do it? Here are the requirements, here are the restrictions. How should we do that? And doing that with our team, came up with a concept, and without ever even seeing a print and apply, we were able to build up this understanding and eventually build this thing that performed even better than what was on the market. So that's what leads us away from what we call often the industry norms or rules of thumb. We have a saying here at Maveneer that if you can't derive the rule or you can't derive the equation, you shouldn't be using it. And oftentimes our industry applies these rules and these rules of thumb, or they see something that they've done before and they apply it to something else without understanding the assumptions or the underlying features. And they're inherently adding complexity in a place that doesn't need it. So blindly applying those rules without really understanding, that's the difference. To be a Maveneer, you have to really understand all the details. You have to dig in and be able to peel away those layers of complexity and drastically simplify the problem into what matters.